Yeah, hello guys, good morning. Okay, and in today's session, we'll talk about Kubernetes. What is Kubernetes? We'll see the installation part. Okay, and apart from that, we'll see some of the basic components available in Kubernetes cluster. Okay, so any idea what is Kubernetes?
Kubernetes is a open source container orchestration system for automating application deployment, scale, and management.
Any role inga headphones March adi. Okay, so let me share my screen and let me explain. I've posted some of the notes in the group itself. Okay, documentation. Okay, so this is what I am going to cover for today. Okay, so if you see the definition of Kubernetes, right? So what is Kubernetes? Basically, Kubernetes we can also call as k8s. Okay, so this is something which is very popular in terms of open source orchestration tool. Okay, which has been developed and used by Google in their production environment. Means before Kubernetes, I mean, before releasing the Kubernetes in market, so Google was using Kubernetes in their production environment. So we can understand how much powerful this tool is because in production environments, Google were using this tool to make sure their application or their servers are always up and running, right? So what do you mean by orchestration now? For example, we are using Docker containerization, right? So Kubernetes will also support containerization platform as well. Okay, means if you want to use Kubernetes, then you should have any containerization platform. It can be Docker or it can be any other containerization tools. Okay, so if suppose if we have couple of containers in our environment, for example, for 5 containers, okay, then it will be easy for everyone to make sure how to manage these containers. Okay, so but whereas if there are 500 containers, in that case it will be very difficult for us to manage. So that's where we need any kind of orchestration tool which will help us to easily scale up our containerization platforms and scale down to manage the traffic. I mean, load balancing and everything can be done with the help of this orchestration tool only. Okay, so Kubernetes is one of such very popular orchestration tool available in the market, and it is an open source tool, okay, which has been developed and used by Google in production environments. Okay, so as part of orchestration technologies, we have couple of different orchestration technologies, like we have Docker Swarm as well, okay, and we have Kubernetes, and then we have something called Mesos as well, and we have ECS and EKS as well. Okay, with the help of, I mean, the advantages, if you check the advantages of the Kubernetes, right? So basically with the help of orchestration, our application will be highly available. Okay, and we can easily scale up our cluster if the demand increases, and also scale up the number of nodes if we are out of resources. Okay, so when I talk about cluster, what do you mean by cluster? Okay, here we are seeing something called node. What do you mean by node? Okay, for example, okay, this will be one virtual machine or EC2, I can say. Okay, and then we can have couple of same EC2 machines. Okay, so in one of these EC2, what we'll do, we'll configure as a master server, master k8s. Okay, and this will be our worker 01 and worker 02. Okay, so these three machines, we, I mean, EC2 or virtual machine, we call them as node machines. Okay, so this can be our node. This will be our node. Okay, and this will also be a node machine only. Okay, so we'll install, I mean, the kind of setup what we are going to see as part of training will be one master machine and two worker nodes. So what will happen whenever if you want to do something or deploy anything or create any pod inside our cluster, right? So basically, we are going to execute our commands in the master machine, and master is responsible to schedule the pods on the worker machines. Okay, so master will send the directions what needs to be done on the worker nodes. Okay, so these three machines, I mean, a general EC2 can be called as a node. Okay, and these two, worker 01 and worker 02, the applications whatever we are deploying, so we can call them as a cluster. Okay, so cluster can be a group of node machines. Okay, and a node will be a EC2 instance. Okay, so now, so as part of, I mean, as part of the basic components, we'll see these basic components, but before this I just want to show you the setup, guys. Okay, so how can we use Kubernetes in our local machine? So we have something called Minikube. Okay, Minikube is a single cluster with all Kubernetes components. Okay, so when I say single cluster with all Kubernetes components means one single machine, one single EC2 with all the Kubernetes components. So here, so what will happen is, if you see the regular setup, right? So we have different components which will be installed in master and which will be installed in the worker machines. Means there is difference in terms of dependencies what we are going to install in master machine. Okay, and there are some components we are only installing in the worker nodes. Okay, so that's how we are making the differentiation between master and worker nodes. For example, if we are installing everything in the master machine, right, and if you are installing all the components in the worker machine, then how we are going to differentiate between them? There will be some components which needs to be installed only on master, and there should be some components which needs to be installed only on worker nodes. Okay, so but whereas as part of Minikube, we are going to install all the components which are required in a single EC2 instance. Okay, in general, Minikube is used for learning as well as development purposes. Okay, when I say learning and development purpose, so if suppose, I mean, as part of training we are going to install Minikube. Okay, if suppose we have some developers who want to test their application in containerization side, right? So if they are trying to develop any application and they want to just test the performance of their containers or their application, then we can set up Minikube into their local machines. What will happen? They will develop and they will try to test the application as well. Okay, but Minikube is not used for production. This is only used for learning purposes. Guys, make sure you are not talking about Minikube in interviews. Okay, Minikube we use only for learning as well as development purposes. Okay, so we will be saying how can we install our Minikube in our local machines. Okay, so as of now, Minikube is already available in my Windows, so I will be changing the laptop. Okay, so let me stop sharing and let me use Harita's laptop.
Okay, hope I'm audible. Yes. So, one second, guys. Yeah, am I audible?
Yes.
Yes. Okay. Okay, let me share my screen. Second, guys. Again. Okay. Okay, let me share my screen. Okay, hope you can see my screen. So let me open Slack documentation. First, we need to install Docker on our Windows machine. So basically, this Minikube setup, I am going to set up this on my Windows machine only. So I will not be using any EC2 or AWS accounts, right? So I'll be installing this Minikube on my Windows machine. So first, we need to install Docker on our Windows. Okay. So why Docker? Because as I said, Kubernetes will be using any containerized platform. Okay. So we need to install Docker. Okay. So let me copy this. So this will be our first step. Okay, Docker desktop for Windows, select this. Guys, let me know if you have any questions in this, okay? So meantime, we'll wait for some time so that this will get completed and we can start installing this. So in previous session, what we have did, we have installed Docker in our Linux machines, right? So here we are going to see the setup on Windows machine. Okay, so when done. Okay. Okay, so Windows installation has been successfully done, but I need to restart my machine. So this will get restart. Okay, guys, I will be connecting back in a few minutes. Record. Laptop has been restarted. So let me share my screen. Okay, so hope you guys can see my screen. So restarted. Then here we can see something to accept. So let me accept this. And here we can see one icon related to Docker desktop. So basically, this is how we can use our Docker. Okay. This we are able to see some updates. So let me click on this. I need to update this. This command. So basically, it is asking me to update WSL version. Okay. So let me copy this and let me open PowerShell. PowerShell IDE. PowerShell by default it will be available in our laptops. Okay. So no need to install PowerShell separately. Just check for PowerShell and try to install WSL package. So this package will be basically Docker is not supportive for Windows. Okay, so with the help of this package, what will happen? So this will make sure to run our Docker on our Windows machine. So this is the kind of Linux update. Okay, let me install this. The term WSL is not recognized, so it is not working. Okay. This package from step 1. Okay, and then let me try to install this. Okay, next. Yes. Finish. Okay, once done, let me reopen my PowerShell. Make this the default version. Okay, whatever we have installed just now, right? So let me make this as the default version. So still this is not working. Okay. Let me try to open Docker now. Okay, now you can see that Docker container, the engine is been getting started. Okay. So if I'll open git bash, if I'll do docker --- version, yes, Docker is installed. Okay. So let us move to step 2. Where is Slack? Okay, so Notepad plus plus. Okay, and then we need to install VirtualBox in our Windows machine. Okay, basically whenever we are trying to install Minikube, right? So it will help us with the hypervisor. Okay, so let me copy this. Let me install Oracle Box now. Okay, click on this link. Okay, and here we want to download this for Windows operating system. So let me select Windows, and then it will download a package, and I need to install this VirtualBox. Okay. Let me open this. Okay, so once this is done, then if I click on finish, then here you can see Oracle Virtual Machine VirtualBox. Okay, so this setup is also done. So now let me close this. Basically, I don't want to use this for now. Okay, let me close this. Okay, and we'll move to step 3. So in step 3, basically, we just want to check the system information. So open CMD. Info. Here basically it will check what are the different components are available and if any hypervisor is installed or not. Okay, if we haven't installed the virtual box, here we can see some error. Okay, so that's the reason I have installed hypervisor, I mean the virtual box, and here we can see a hypervisor has been detected. Okay, so and we are able to see the different IP address and everything. Okay, so this is also okay. And now let me go to Minikube installation. Okay, so let me copy this document, and here we need to use PowerShell to install Minikube. Okay, so if I'll paste this in browser. Okay, so the basic requirement, it should be 2 core of CPUs. Okay, and 2 GB of RAM and 20 GB of our hard disk space. And it should have any kind of virtual machine and Docker to install. Okay, in our case, we have already installed Docker as well as we have already installed VirtualBox as well. Okay, so we have the prerequisites. So let me go to Windows. Okay, let me try to copy this command. First command, okay, go to PowerShell, open PowerShell. Can paste that command and hit enter. Okay, it will try to download Minikube in our Windows machine. Okay, so it will take some time to finish this up. So let me minimize, and then we need to execute this command. Basically, we are trying to add our path in the system variables. Okay, so just wait. Okay, this is done, and let me copy the second command. Okay, and then open PowerShell, hit paste. Hit enter. Exception request access is not environmental variable. Okay, that is fine. So we have installed Minikube. Now let me set the Minikube part to environmental variable. Okay, so how are we going to set this environmental variable? Just go to edit the system development. Okay, go to environmental variables. Okay, and then let me first copy the path of Minikube. Okay, Windows C, where we have downloaded. Let me go to C. Okay, here we have our Minikube. Let me copy this path. Okay, and then go to your system variables. So select path, click on new, or else. Let me do one thing. Let me edit this. Okay, new, and then save. Okay, okay, okay. Step 5 is also done. Now I just need to restart my PowerShell and start Minikube by using the command called Minikube start. Okay, so let me close my PowerShell. Okay, let me use. Do you have Visual Studio, right? So let me open Visual Studio and try to access from Visual Studio. Either we can use any terminal, whether Visual Studio, PowerShell, or CMD, I mean Git Bash. Okay, so terminal, new terminal. Stuff. So this will take some time, and then this will start our Minikube setup. Okay. Pulling the, see, basically what it is trying to do, the moment I have executed Minikube start, so it has been trying to pull some of the base images. Okay, even our Kubernetes images will be in terms of containers only. Okay, so this will take some time. Guys, let me know if you have any questions. It will take some time. It will try to pull all the base images, and it will make sure to start our Minikube server. Okay, we need to wait for some more time.
Mr. Bond,
Sorry.
I have one question.
Yeah.
So before Kubernetes, so what DevOps team used to work, how they use the help of Docker itself, or are there any other tool they have?
So basically, we had Docker Compose. Okay. So or else if still it is in terms of containerization, then we had our physical machines only. I mean that was a kind of really complicated architectures where they need to really scale up their environments. I mean regular EC2s only. Okay, with the help of Kubernetes, everything has been very easy, and they are able to manage their infrastructure and scale up and scale down at very easy point of time. Okay. So now, if you see this, the setup is done. So we have got something called kubectl is now configured, or use minikube cluster and default namespace by default. So what is this? Okay, so first thing is I just want to check the IP address what my minikube has got. Okay, so minikube IP. Then here I can see that 192.168.49.2 is the cluster IP. Basically, with the help of this IP address, we can access our applications. Okay, so if you want to log in into your minikube, right? So we can use a command called minikube ssh. And then here we can see that you have been logged into the minikube container. Okay, now let me exit. Okay, and let me show you something. Docker ps. See, the moment I'm executing Docker ps here, we can see one base image has been downloaded, which has been running from last 2 minutes, and this has been exposed on port number 50,663. Okay, and the name of this image is nothing but minikube. So whenever I have executed minikube start, what happened? One image has been downloaded, and this image contains all the configurations related to our setup. Okay, now we have something called kubectl. Okay, the moment I'm trying to hit this, so we can see a lot of options over here. Okay, so what is kubectl? So if you want to communicate with your Kubernetes cluster, right? So we have command line tool that we call as kubectl. Okay, and this is much popular. So generally we use kubectl commands to communicate with your Kubernetes machines, clusters, or containers. Okay, now or else I can use minikube command as well, but since this will not be a part of our production exercise, right? So I will be using kubectl only. So what is kubectl? Kubectl is nothing but a command line tool to communicate with our resources in our Kubernetes cluster. Okay, so we have one command. So let me open this document. So we have one command called kubectl get pods. So let me check this get pods. Okay, here we can see no resources found in default namespace. So what do you mean by pod now? Our setup is done in our local machine. We are able to see kubectl is getting executed, and we are able to create any containers as well. Okay, but what do you mean by pod? So pod is nothing but a smallest unit in Kubernetes. So what pod generally contains? Pod contains of container means okay. This is our pod. Okay, and inside this pod we'll have our containers. These containers will be running on Docker only, right? So we can see containers inside our pod, and pod is nothing but a smallest unit of Kubernetes cluster. Okay, so inside pod we can see our containers. So what we have seen in Docker, we used to directly run our containers and we used to connect to the containers, right? But whereas in Kubernetes that is not possible. If you want to create any container, then we need to create one pod. Inside the pod only we can see our containers. Okay, and we will be seeing the IP address assigned to pod 192.168.0.1. For example, this IP address will be assigned to one pod, not to the container. Okay, so inside pod we can have one container, we can have multiple containers. Okay, that is up to us, but it is not recommended. Generally, we can see only one container inside one pod. Okay, but it is possible to create multiple containers inside the pod as well. Okay, now what I am trying to fetch is kubectl get pod. So I just wanted to check if there are any pods which has been created. No, right? So this is how we can connect to our cluster and we can check if there are any containers or pods which are running in our machine or not. Okay, so guys, clear? So this is how we need to set up our minikube. So now let us move to the Kubernetes 3 node setups. Okay, where I will be creating one cluster, one master machine, okay, and 2 node machines. So for this, I need to launch 3 instances of type t2.medium and annex to AMIs. Okay, so t2.medium, why? Because we need at least 2 core of CPUs, right? And also some enough memory to run our cluster. So that's the reason the type of this instance will be t2.medium. Okay, so let me go to AWS now. Let me do one thing. Let me switch back to my laptop only. Okay, so let me use my AWS account. So let me stop this recording.
Okay, so let me share my screen. Okay, so where is my AWS? Hope you guys can see my screen, right?
Yes.
Okay. Okay, so this is Ohio region. So let me, as part of setup, so let me provision 3 instances of type T2 medium. That is the minimum requirement. So let me use launch instance. So we are not using any of the AWS services. So we are using standalone Kubernetes setup. Okay, so this is how we are going to set up in our virtual machines as well. Okay, names, I don't want to give any name, and then T2 version 2 Linux images I want to use, and here the type should be T2 medium, and then keygen will be, let me create one keygen, k8s, create key pair. Okay, and then I will be configuring 20 GB for them. Okay, 20 GB of memory. And networking settings, I just want to make sure if the public IP is assigned. Okay, so let me edit this, enable public IP. Okay, this is done. Select security group, existing one, so I will use default because already everything is opened in my default security group. Click on launch instance. So it will take a couple of minutes to provision our instance. So till then, let me configure the names. So Kubernetes master, and then this will be my worker 01, and then this will be my worker 0. Okay, so now we have created 3 instances, and then we need to disable swap memory. The reason why we want to disable swap memory is because we want our Kubernetes to utilize 100% of our CPU. But default in AWS, swap memory will be 0 only. So no need to disable this. We can ignore this part in AWS. If you are working on any virtual machines, then you need to check for this. Okay, so then let me start. Okay, so I have got one master, so let me try to connect SSH client. Let me copy my PIM key, and then where is my keygen, which is in downloads, right? So right click, git bash here. Okay, hit enter. Yes. Okay, let me switch to root user. I want to install the setup by using root user only. Okay, so this is my master machine, guys. So this is master, and then okay. So if I'll check free -h, right? So here we can see free -h swap memory is 0 allocated. So no need to make any changes. So we can ignore this part. But apart from this, if it is IP 192.168, right? So this is very difficult for me understand which is my master machine and which is my worker. So what I will do, I will change the host name. Okay, vi/etc host name. Okay, let me change the host name to master. Now if I'll do host name, I need to restart this. Okay. I need to sign out and sign in again. Host name, right? So systemctl restart SSSD. This is not working. Why? cat/etc host name. Okay, let me try to connect to the session manager. So basically, just for my identification, I just want to change the host name, or else it will be very difficult for us to switch from master to worker to understand or to remember the IP addresses. Okay, so echo dollar etc host name. Okay, let me refresh this. Yeah, so now we can see here we can see as master. Okay, the host name has been changed, so we can easily identify our machines now. So now let me try to exit this, and try to again connect. Okay, yes, sudo su ifa. Okay, so this is my master machine. Now let me try to connect to my worker 01. Okay, worker 01 connect. Session manager, sorry, EC2 instance. Let me connect. First name, I just want to change this first name to worker 01 sudo. Okay, if I'm trying to do host name, vi/etc host name. So generally, we can permanently set this in the etc host file name. Okay, so vi/etc host name. Okay, worker 01 is also configured. Now if I'll refresh, so let us see what will happen. Okay, now we can see worker 01 here. Okay, so let me close this as well and try to connect from my git bash only. Okay, git bash here, and then is the IP. Yes, sudo su fun. Okay, and then we have got our worker 01 host name. Okay, so worker 01 is also ready. Now let me open worker 02. Well, this setup will be somewhat lengthy, but this is one-time activity what we are going to do. Okay, so after this setup, make sure that you are not terminating your instances. Okay, or else it will take a lot of time for you guys to set up again and again. Okay, so just shut down your instances after your practical, because this is what we are going to learn for next 7 days. Okay, so make sure you are not switching, I mean you are not turning off your EC2 instances. Just shut down but do not terminate. Okay, vi etc hostname worker 02. I have changes. Now if I try to refresh, I hope this will be reflecting now. $, hostname. Must be root. Okay, sudo. Okay, now let me refresh. This should be worker 02. No. Okay, done. Okay, so now let me try to connect via git bash only. I don't want to use the session managers. What happened? Okay, so we have our master machine. I'm in the root user, and then I have my worker machine root user, and then I have my worker 02 in the root user. Okay, so now we have some components which needs to be installed in both the master and worker nodes. Okay, so let us see that. So first thing is Docker based operating system in 3 instances. So basically we need to install Docker in all the 3 machines, because that's how we are going to run our containers, right? So Docker is a common component which should be installed in all the, even in master as well as on the worker node. So let me install Docker. So we have that command, right? So -y install Docker. So I don't think so we need to check the documentation, so we can use this. And same command I will be executing in the worker 01 as well, -y install Docker. Okay, and then I will be executing in worker 2 as well. Okay, -y install Docker. Okay, so I have been executing in 3 machines. So in master this is completed. So let me start my Docker systemctl start Docker. Okay, Docker is started. So let me enable this Docker as well. Basically, even if I'll start my machines tomorrow, right, after shutdown and start, then Docker should be automatically starting up. Okay, so this is also done. Same thing I need to execute in worker 01 systemctl start Docker. Okay, and then I need to enable Docker. Okay, systemctl start Docker. Okay, and then systemctl enable Docker. Okay, so we have executed all these 3 commands in all the 3 instances. So in our work master as well as 2 worker nodes, we have installed Docker. Okay, so now once this is done, to set up Kubernetes cluster, we have different tool like k8s and k8 kubeadm. Okay, so in our case we are using kubeadm. Okay, so let me copy this link. Let me check what can be done. Okay, installing kubeadm. So basically if you see this documentation, right, so 2 GB RAM, 2 core of CPU, so this is what we are already having, right? So this will not be a problem. And sudo swap off, so we have our swap memory disabled, so this will not be a problem again. Okay, then if I'll scroll down, we have our Windows that is also running. Okay, now ours is a basically Linux based environment, so right. So let me go to Linux based system. Okay, and let me copy this command. So what kubeadm will do? Kubeadm will help us to set up our Kubernetes cluster. So I need to copy this. Basically we are trying to download some RPM packages repositories. Okay, RPM packages, and then I can use kubectl install command. Okay, so let me copy this command. Okay, clear up. I'm executing this in master. Okay, same command I will be executing in the worker 01 as well. Okay, and then same command I will be executing in worker 02 as well. Okay, so this is done. Now let me scroll. So basically in Linux, in Amazon Linux, this is not required. So I will be ignoring this, or if you want to execute, then you can execute this as well. Okay, but in our case, I don't think so this is required, but still let me execute. Okay, so paste. Paste in all the three machines. Okay, so if we have 10 servers, one master or 9 worker nodes, then we need to execute this in all the 10 worker nodes. Okay, so this is also done. Now let me install. Here if you'll see sudo yum install fny. So we are using kubelet. As I have said, kubelet is nothing but one command line tool to communicate with our cluster. And then we have kubeadm. This will be the administrator thing. Okay, and then we have kubectl. Sorry, kubectl was the command line tool, and kubelet is a different component of Kubernetes. Okay, so let me copy this and let me execute this in master machine first, and then I'm executing this in the worker 01, and then I'm executing this in worker 02. Okay, so the whole idea basically is, if suppose something got changed in future, right, then you should be able to understand from this documentation. Okay, so that's the reason I have been pasting the documentation links. Okay, and then now let me try to start Kubernetes or kubelet. Okay, so in master machine, let me execute this. Okay, and same thing I am enabling in the worker 01 and in worker 02 as well. Okay, so this is done. So if I scroll down, I don't think so we have anything left. Okay, so we are good with this step 4, and now we need to set up networking and configure master and worker node. So basically what will happen is, so whenever the pods whatever we are going to create, it should assign one IP address, right? So for that part, we need to provide any networking provider to Kubernetes. Means either you can create your own networking, or else we can use the existing networking solutions which has been provided by Flannel, Calico, and we have couple of more companies who has provided the networking solution. Okay, so as of now, let me use this. Okay, so in step 5th, if I'll open this, okay, okay, if you see this documentation, right, so this is what it is mentioning about the networking part as well. I mean, how can we create a cluster with kubeadm? But before this, we need to provide any networking solution. So what I have did is, I have configured this in the step 6. Okay, so I will be using Flannel as part of my networking solution. Okay, so you can just copy this and hit enter. So basically this will be the range of CADR for our pods which are getting created. Okay, let me copy this. Let me clear the screen in master machine and let me hit enter. Okay, this is taking some time to provision. So once we execute this, basically step 6 needs to be executed only on master machine. Okay, if you see, to configure master, we need to initialize with CADR. Okay, so once this is done, it will take some time. If the networking part is okay, then we can create our Kubernetes cluster. Okay, see, here we can see something called Kubernetes control plane has initialized successfully, and then here we can see three commands. Okay, to start using your cluster, you need to run the following as a regular user. So let me copy this. This is what I have mentioned in step 7 as well. Okay, so let me copy this, and before this, let me copy this one as well, and let me copy this and save. Okay, Control C, Control V. Okay, so what is happening is, so we need to specify one master and one kernel node. Okay, so as part of the installation, what difference we have seen, we have installed planner or the networking solution only on the master machine, not on the worker nodes. Means the networking solution is one extra component available in our master machine. Okay, apart from that, if you want to use your cluster, it is asking us to configure this. So this is nothing but something related to the credentials. Okay, and apart from this, here if you see, then you can join any number of worker nodes by running the following on each as root. Means if you want to add worker nodes, worker 01, worker 02, worker 03, worker 04. So you need to copy this command and add this command or hit this command on the worker 01 and worker 02. Okay, so first let me finish this up and let me show you that. So let me copy. Okay, I think we have some added spaces here. So let me remove this space. Yes. And then sudo ch1. Okay. Hit enter. So we have executed these three commands successfully on the master machine, and then it is asking us to join this. So what will happen? So how will Kubernetes master know how many worker nodes are available? Okay, so let me show you something. So if I'll execute kubectl get nodes, because kubectl we have already installed, right? So get nodes will help us to get the number of nodes which are available in our cluster. Hit enter, see what will happen. Here we can see only master machine is available. There are no worker nodes in our machine. So get nodes will get the information of your node machines which are connected. Okay, so we have only master as of now. There are no worker nodes configured. Why? Because we haven't executed this command on the worker 01 and worker 02. Okay, so what will happen is, if some random machine is trying to connect to my master and tell that I am your worker, please join. So what will happen? Master will not allow them. So basically, master is expecting they come with this token number. You should come with this token number, and I will validate this token number. If this token number is validated, approved, then only you can join to my cluster, or else master will not allow. Okay, so that's where we are using this kubeadm join command to connect to our master machine. Okay, so any random machine xyz cannot come to my master and tell that please join me as your worker. No, even if any machine wants to join as worker, they need to come with this token number, or else this will not be allowed. Okay, so let me copy. Okay, in worker 01, let me paste, hit enter. Okay, it will take some time. And then on worker 02, let me paste and hit enter. Okay, same command I have executed. Okay, so worker 01, we can see this has been successfully done. Okay, let me go to my master machine and clear this one. Okay, kubectl get nodes. Now we can see one master and two worker nodes are ready in our cluster. And it's been, age is from last 4 minutes 14 seconds, and it has been from 22 seconds. This is from last 14 seconds, and this is the Kubernetes version what we have installed. But here if you see the status, this is not ready. Why? So let us see this, what happened, why our machines are not in ready status. Okay, so once this is done, here if you see this, if you execute kubectl get nodes, we can see the status of as not ready, because we haven't installed flannel. Okay, basically this is something what I was talking about, I mean the networking solution. Okay, so in order to install flannel, we need to copy this command. Okay, and paste this command in your master machine, hit enter. Okay, once this is done, if I'll do kubectl get nodes, we can see still something is happening, but still it will take some time. See, two worker nodes are ready, but master is still not yet ready. So what happened to master? Now see, master is also ready. Means we have one active master machine and two worker nodes. So you can think as master is a king and workers are the slave machine. So king will inform what needs to be done and what needs to be not done, and workers will perform that activity. Okay. So we have copied the token as well, right? So I think we are good with the setup of master and worker nodes in Kubernetes cluster. So we have one master and two slave machines. So kubectl get nodes, we can see one master and two worker nodes. Okay, now if I execute kubectl get pods, so let us see what happened. Okay, we can see no pods. So okay, if I execute kubectl get pods f1a capital A. Okay, here we can see some of the components which are being running. So -a basically represents the hidden one. Okay, so here we can see some pods are being executed in the background. So this is what maintaining our cluster. Without these pods, we will not be able to set up our cluster. Okay, so here if you see this, three pods with flannel. So one in master and two in worker nodes. Okay, and then we have kube system code DNS, and we have etcd, we have API server master, we have controller, we have kube proxy, we have kube scheduler master. So what is what are all these containers or pods? So these are the master components which are responsible to run our clusters. Okay, so each component has their own specifications and their purpose for what these are being running on our machine. Okay, so we are good with the setup of Kubernetes Minikube as well as Kubernetes cluster as well. Okay, so if I'll go to my Minikube, what I have been using Visual Studio Code. Okay, the reason why we will be using our Kubernetes Minikube, our Minikube service is there is no billing charges on our local machine, right? So there are every time it is not required for us to execute on the Kubernetes master server, as part of training. So we can check from here as well. Okay, so if I'll see this Minikube, let me execute kubectl get pods. This is not running. Basically, I think my Minikube is off. Okay, let me start my Minikube. Okay, this will take some time. So we have our Minikube setup in our local machine as well as our standalone Kubernetes cluster of production environment, I can say. So if suppose now you have one more worker node, so what we can do? We need to install few of the components which are required, like Docker is installed, and what we have installed kubelet. Okay, and then we install our we need to join our worker to master by using kubeadm join command. Okay, so that components are required. So hope this is clear. Guys, let me know if you have any questions, or else we'll proceed with other components. Cheppu Palwan.
కాదమ్మా, if in case మాస్టర్ నోడ్ అనేది డౌన్ అయిపోతే నెక్స్ట్ స్టాండ్ బై ఇన్స్టెన్స్ ఎలా సెటప్ చేస్తాం?
ఇప్పుడు ఉన్నది ఒక మాస్టర్, అది డౌన్ అయిపోయింది అనుకో, అవన్నీ తర్వాత చూద్దాం. ఫస్ట్ సెటప్ గురించి చూద్దాం. నీకంటే తెలుసు, వేరే వాళ్ళకి తెలుసా వాట్ ఈస్ క్యూబర్నెటీస్? తెలియదు కదా, అప్పుడు ఎందుకు డిఆర్ గురించి మాట్లాడతాం? ఓకే, ఇప్పుడు జరిగిన దానిపైన ఏమైనా డౌట్ ఉంటే అడుగు, జరగబోయే దాని గురించి ఇప్పుడు ఆలోచించకు. ఏమంటావు? ఎస్ ఆర్ నో? ఓకే, stick to what we have seen from last 1 hour. Okay, so how we are doing to set up multiple node machines or standby master, that part we'll see when we progress. Okay, but as of now, let us focus on the setups only. Okay, So now we'll see what are the different components. Okay, so as I have said, right, so basically we have some basic Kubernetes components. Okay, so one of the basic component is pod. As I said, pod is nothing but the smallest unit of Kubernetes. A pod can contain one container, multiple containers, or one container and one volume. Okay, IP will be assigned to pod. Means, so this is our, so for example, when I'm trying to execute kubectl, okay, so kubectl is the command line tool, right? So I'm telling kubectl and install any pod, right? So what will happen? This kubectl command will get executed on any of these worker node. Okay, for example, on this worker node, this is scheduling. Okay, so what will happen? Here we can see one pod. Okay, inside this pod, we can see our container install. Okay, inside this pod we can see our container is installed. Okay, and to this pod IP address is assigned. Okay, IP is assigned to the pod. Okay, so always remember that whenever I am talking about pod, it means that I am talking about a container inside that pod. Okay, pod, generally what is pod having? So pod can have one container, multiple containers, one container, one volume. Okay, and the IP will be assigned to pod only. Okay, now, and then we have one more component. Okay, we call it as replica setter or replica controller. So what is this? Okay, as of now, I just want you guys to understand this, because as we progress, right, you will be hearing about pod, replica set, deployments, each and everything on a regular basis. So I mean, I want you guys to be at least in a kind of state that you have heard about this, right? So what do you mean by replica set? So replica set is a service in Kubernetes which will make sure the number of pods running on the node machines. Means what will happen if suppose we have configured one pod here. Okay, we have configured one pod here, right? So if for any reason, if the pod is not healthy or if this pod has been deleted, so what will happen? So replica set or replica controller will make sure that this pod is running on the node machine. Basically, this is replica set or replica controller. So we have two components. So latest is replica set. So previous one was replica controller. Okay, so replica set is responsible to monitor that pod. Okay, it will keep on monitoring, and if it is not healthy, then it will make sure to replace a new pod at that same place. Okay, and then we have something called deployment. So what do you mean by deployment? Basically deployments are responsible to deploy, upgrade, undo the changes, pause, resume the changes. Okay, so if we have got a new version of application, right, so that's where we are going to use deployments. So we use deployments to deploy our application, update our application, or make any changes in our application. I mean, modify in our application. Okay, so in deployments, again we have two type of deployments. Okay, so we have rolling updates as well as we have recreate deployment. Okay, so we'll talk about recreate and rolling update whenever we are working on it. Okay, so and then we have something. Okay, if you'll see the hierarchy of deployments, right, so we have talked about pods and we have talked about replica set as well. So inside deployment, we can find replica sets as well as our pods. Means, let me open this. Okay, for example, this is our container, right? So this is our container, and our container is inside our pod. Yes. Okay, and this pod will be inside our replica set. Okay, inside our replica set we can configure our pod details. Okay, and this replica set is again inside the deployment. Okay, So we have our container which is inside our pod is inside our replica set, our replica sets are inside our deployment. So you can understand that whenever we create deployment, we are also creating replica set as well as we are also creating pods. Okay, so this is how the deployments will be working, and deployments are used to deploy, upgrade, and make any changes in our deployments. Okay, and then we have something called namespaces. So namespaces, we are using namespaces to group our applications. For example, if we have 5 different teams in our company who are working on same Kubernetes cluster, in this case, how are we going to segregate their applications? There might be a chance that the name of their application and our application or any service whatever we are trying to give, right, there might be a chance that it might be same. Again, it will create a confusion, right? So that's where we use namespaces, and namespaces are very important in Kubernetes. So namespaces will help us to segregate our applications or share our Kubernetes cluster between different teams. Means on same cluster, if five teams are working, right, so they will have their own dedicated namespace. For example, in one office building, we can see IT department is working, testing team is working, HR is also working, finance team is also working. But what will I mean on in one floor, what generally they will do? They will keep the IT department people at one place, I mean in a different compartment. Finance department will be in one different compartment. Okay, and testing team will be in one different compartment. So that's how we are sharing the same space. Okay, even with the help of namespaces, we are going to share our cluster with different teams. Okay, and then we have something called services. Services will basically help us to redirect the traffic to our pods. Means if suppose any user is trying to access our Kubernetes cluster, so that's where we can see services are helpful for us. Okay, guys, understood? Apart from Ahmad and Ashfaq, I don't think so anyone else is responding. Are you guys listening or sleeping or what? Okay. Okay, and then we have, I mean, this architecture we have already seen. So we have one master and we have worker node. Okay, so if we'll talk about the master and worker components, right, so in master components, so as I have said, so what is making the differentiating, I mean what is differentiating between the master and worker node? So we have these 4 components installed in our master machine. One is Kube API server. So if I'll open this, okay, and if I'll show you the screen, right, so here we can see first one is Kube API, right, here Kube API, and here in master we can see Kube API server. Okay, and then etcd. Okay, then we have etcd. Okay, then controller, then we can see controller is installed. Then we have scheduler, then we can see scheduler is also installed. Okay, so these are the important components in master machine. Okay, if you'll see worker node components, here we can see Docker is already installed in our master machine as well. Okay, and kubelet is also installed. Okay, and kube proxy, here we can see 3 components. Okay, one is in master, one is in worker 01, and one is in worker 02. For example, let me show you this. -o void. So basically -o void means what will happen? Okay, the moment I'll execute -o void, so what will happen is it will give me the complete detail. Okay, here we can see the IP address and which node it is been installed. Okay, so if you see this kube flannel is installed in master as well as both the worker nodes. Okay, here if you see this in worker nodes, we can see something called core DNS. Okay, and etcd is only installed in master machine. Okay, and then we have API server. This is also installed only in master machine, and then controller is also installed in master machine. So kube proxy is installed in master as well as worker machines 3. Okay, and then we have kube scheduler. This is installed in master machine. Okay, so with the help of -o void, we can get the complete details of our current command. Okay, so here, so these are the 4 components what we have installed in the master and in worker node, and Docker is common in all the 3. Kubernetes is also common. Okay, and kubeproxy is available in master as well. Means in worker machine, only 3 components we have installed. One is Docker, one is kubelet, and one is kubeproxy. Okay, and then we have something called kubectl. As I said, kubectl is a command line tool to execute Kubernetes commands. Okay, means whenever you want to communicate with your Kubernetes, then we can use any command line tool. In our case, we are using kubectl. Okay, and then here we have something called kube API server, right? So what is this? Okay, so let me show you this. K8s components. Let me go to images. Open image in new tab. Okay, here we, if you see this control plane. Okay, control plane is nothing but our master machine. Okay, so these are the different components available in our control plane, that is API, scheduler, etcd, controller manager. Okay, and then the scheduler. Okay, and these are the different components in our new node machine, that is kubelet, kubeproxy, and docker container runtime. Okay, so what is happening is, so when we talk about kube API server, right? So what do you mean by kube API server? Kube API server will act as a front end of Kubernetes. Okay, authenticate user, authorization will be done, and API server is the only gateway to communicate with our Kubernetes cluster. Means whenever I'm trying to execute, for example, I'm trying to execute kubectl get pods, what will happen? Sorry, spelling mistake. Okay, whenever I'm trying to hit kubectl get pods, what is happening? This command is communicating with my API server. That's where we call this as front end of our Kubernetes cluster. Okay, front end means I can say as, if suppose you want to get inside Techie Horizon. Okay, if you want to come inside Techie Horizon, so what is the front end? The main door. Okay, from that main door only anyone can come inside our institute, right? So same case, if you want to communicate or get inside your Kubernetes cluster, we need to communicate with API server first. Okay, so that's why we are calling API server as front end of Kubernetes. Means we are communicating with API server. The moment I will hit kubectl get pods or any other command, then it will communicate with the API server, and it will authenticate user. Means we have 2 things here, authentications and authorization. What is the difference between authentication and authorization? Any guess? Any idea, guys? So basically what, yeah.
Authentication is nothing but giving a proper username and password. On authorization, it's like giving access, right?
So basically what will happen is, okay, whenever if someone is trying to access our Kubernetes cluster, it will communicate to API server. Okay, and then API server will authenticate the user. Means the user ID and password, I can say, whether that user has access or not. Okay, whether he is providing the right user ID and password to communicate with our cluster. Okay, and then authorization means whether, if even the user ID and password is right, whether he has access to access our applications or not. Ante, got it? Okay, so authentication will check for the user ID and passwords, whether he has the user ID and password access or not. And then authorization means whether he has access to get the details of my pods, whether he has the access to get the details of my node machines. Okay, so that's what this will be doing. Okay, so API server is acting as a front end, and then it will authenticate the user who is trying to access, and then he will check whether the authorization, whether he has the access to get the details or not. Okay, and then it will send out the output to that user. Okay, and API server is the only gateway. Means if you want to communicate with our cluster, then API gateway is the only option how we can communicate. Okay, guys, hope this is clear. If not, then let me know, because Kubernetes is very important and this will be asked in interviews. So this, raised your hand whether you have any question or you're okay with this.
Okay, sir.
Okay. And then we have something called etcd. Okay, so we have talked about etcd, right? So someone will be calling this at etcd, someone will be calling this as etcd. So basically etcd is nothing but the cluster brain which stores the information related to cluster or related to node, related to the node in the form of key value pairs. Basically, if you see this diagram, okay, so what will happen is etcd is nothing but the brain of our Kubernetes cluster. This is a kind of storage, okay, because if suppose, how many nodes do we have as of now? How many nodes have we created, guys? How many nodes have we created?
Two.
Two nodes. Have we two worker nodes or and one master? Okay, three nodes. Okay, so have we created any pods? No, right? So all that information will be stored in etcd. Okay, how many nodes are available, how many pods are available, which pod is healthy, which pod is not healthy. So each and every detail will be stored in etcd. So we call this as cluster brain. Okay, so and then we have something called scheduler. So what is scheduler? Okay, the scheduler is sorry,
Distributing load. Workload.
sorry.
Distributing workload.
Basically, scheduler is responsible to schedule the pods on the node machines. Okay, so not exactly I can say as distributing the workload, but scheduler is responsible to schedule the pods on the node machines. Okay, so whenever we are trying to execute our kubectl commands, right, to create one pod, so what will happen? Scheduler is responsible. Okay, so what will happen? Scheduler is responsible to check which node is free, which node we can schedule the pod. Okay, so scheduler is responsible to do such kind of activities. Again, from where scheduler will be getting the complete detailed information? I mean, how scheduler will understand where it needs to push this? Okay, or else open, let me open this. Okay, how scheduler will know in which node is available, where we can open our, it can schedule the pod. Okay, here if you'll see this, okay, control plane, worker node. So this is etcd, control manager, scheduler. Okay, so anyone who is trying to access will be connecting to API server only, and then even scheduler, it will send out the request to API server only. Means scheduler will get the detail which node is having how much space, where a container can be run, right? So that information will be gathered from etcd only. Okay, scheduler will get that information from etcd only. So that's how scheduler will know how many node machines are there, in which node machine there is space, in which node machine it can schedule the pod. Okay, clear, guys? Okay, and then we have controller manager. So what do you mean by controller manager? Controller manager is the brain behind orchestration. If nodes, containers, endpoints goes down, then controller will work behind them to bring up. What do you mean? I mean, this is kind of complicated sentence, right? So in simple terms, controller manager will make sure, for example, we are using air conditioners in our home, right? So if you set the temperature for 25 degree, for example, so what will happen? It will maintain 25 degree only throughout the night, right? So if you are using air conditioners and the temperature is set on 25, then how the air conditioner is knowing whether the temperature is 25 or not? Okay, so we can say as controller manager. Basically, what will happen is the controller manager will check if the temperature is 25 or not for every frequent time. If the temperature is 25, then it will maintain the same temperature. If suppose, and the AC will temporarily get shut down. If suppose the temperature has been increased to 27, right, then again what will happen? The controller manager will check, okay, the user has asked me to maintain the temperature of 25, but the room temperature is 27, so I need to start the AC. Okay, so that's what controller manager is doing in our air conditioners. Okay, so similar to that in Kubernetes cluster as well. So controller manager is responsible. For example, if any of the node machine is not working or down, or the containers are not running, okay, or if the endpoint means services are not running, or okay, so if something is happened, then controller manager is responsible to make sure that these many nodes are working, these many pods are running. Okay, if suppose I have asked to run 5 pods, okay, if suppose I have asked to run 5 pods, then controller manager will always keep a check on that. If the pod number is 4 for any reason, then controller manager will send out the alert and it will create one new pod for us. Okay, so that's where we call it as the master brain behind the orchestration. Okay, and then we have container runtime. So this is Docker. Okay, so which will help us to start, stop, pause, resume our containers. Okay, and then we have kubelet. Kubelet run on all machines. Okay, means kubelet is installed on our master machine as well as our worker node. So I'll show you this. Kubelet, where is kubelet? If I'll show you this kubelet -f1 version, see, you can see this kubelet is installed in master as well as kubelet -f1 version. You can see kubelet is installed in worker 01 as well. Okay, so kubelet is installed in all the master machines and worker nodes. Okay, and then what are we expecting from kubelet? I mean, what is the responsibility of kubelet? Okay, if you see this kubelet, make sure that the containers are running and expected node machines. Means kubelet will check the containers whether they are running as expected on the node machines or not. Okay, so each and every tool, I mean every component is interlinked between them. It's a kind of two-way communication, I can say. Okay, so kubelet is responsible to check the containers are running on the node machines or not. Okay, and then we have kubeproxy. Okay, so kubeproxy basically it will maintain the networking rules on our node machines. Okay, basically if we have two node machines and we are running some pods on our machines, right, kubeproxy is responsible to manage or maintain the networking rules. I can say as routing table. Okay, what routing table was doing? It was creating the role or the routes where it needs to get connected, right? So similarly, kubeproxy will help us with such kind of cases. Okay, so this is all about Kubernetes components. Okay, and then guys, let me know if you have any questions. No. Okay, let me move ahead with how to create a pod. Okay, so as I have already discussed, pod is the smallest unit in Kubernetes. pod will have at least one container, means minimum requirement for pod is one container. Okay, so in general we can have multi-container pods as well. Okay, so we can have multiple container in one pod, one container with application and another container will be our helper container. Means what will happen is, okay, so what will happen is, for example, this is our pod. Inside this pod we can have one more container as well. This is also possible. In this case, this is our application pod. Okay, this is our application pod. Guys, this is very important and this will be asked in interviews. Okay, application pod. And this pod we call this as helper pod. Sorry, not pod, helper container, because already we are inside the pod, right? So I'm sorry, not pod. Basically this will be the, okay, this will be application related container and this will be helper related container. Means within one pod we can have multiple containers as well. One will be related to application, one related to dependency. We generally call it as helper container. Okay, so if you see this definition, one container with application and one another container will be helper container. Helper container, what will helper container will do? This will be deployed along with our application. Helper container will help our application with any processing or functionality. Basically, if we have one application and there are some dependencies which needs to be installed, right? So in that case we can go for multi-container pods. Okay, so the second container we generally call as helper container. Okay, now let us see how can we start one pod in our node machine. Okay, so let me copy this kubectl run first pod -f1 generator equal to run -f1 pod /v1 -f1 image nginx. Okay, so let me see what is happening, and then I will be explaining this command. Okay, don't worry. So for now I can either use my minikube. Okay, I can use minikube as well because this will execute in the local machine, right? So I can use either my minikube or else I can use my Kubernetes cluster. Okay, so let me use Kubernetes master only. So what will happen? So if I execute this kubectl command not found, what happened? Kubectl get pods, get nodes. Yeah, status is also up and running. Right. Okay, let me try to run this same command in my minikube and check if there is any issue with this command or what. Yeah, kubectl first pod, this is working only. Okay, let me copy the same command. What the hell is happening here? kubectl -f1 help. Okay, basically if you'll see -f1 help, right, so we can get lot of information, what command can be used, what can be done. Okay, so I was using run, this was my pod name and that was my image. Okay, let me try to run again. Kubectl run first pod -f1 image equal to nginx. Yeah, maybe there was some gap in the spellings. Okay, I mean in the command. Okay, here when I have tried to execute it, kubectl run first pod -f1 image nginx, what we can see something called pod/first pod created. Okay, so here if I'll segregate this command, right, so first pod is nothing but the name of my pod. Okay, and generator basically it is to specify pod, if it is deployment, or pod whether it is replica set, whether it is service. So ignore this for now, no need to worry. Okay, and image is nothing but which image you want to create or you want to pull from Docker Hub. Okay, so if you see the node, generators might be deprecated. Basically these generators are deprecated for now. Okay, this is not working. Okay, now if you see kubectl get pods, then we can see the list of pods which are running on our machines. Okay, with the help of kubectl get pod, what I can see there is one first pod which is running, and if you see the status one by one, means out of one pod one is running and the status is running, 0 restarts, and this has been started from last 57 seconds ago. Okay, so this is how we can create one pod in our Kubernetes cluster. Okay, so here we have some basic commands. Okay, kubectl get pods. If suppose you want to get the complete detail, okay, kubectl get pods, you want to know on which particular worker node this pod has been created. In this case, you can use -o void, and if you hit enter, here you can see first pod status running, age 105, and IP address of this pod is 10.244.2.2. From where we got this IP? If I scroll up into the installation part, if you see the CADR range, see this is from where we have got the IP address range, because we have used the existing networking solution, right? Okay, so from here we got the IP address. Okay, and then here we can see this has been scheduled on worker 02. And then here we can see some readiness gate dominated nodes. We can ignore this for now. We'll talk about this as later point of time. But as of now, if you want to get the complete detail, then we can use kubectl get pods -o void. Okay, and then if you want to get the detailed information of the pod which has been created, for example, okay, let me use something kubectl. Okay, I want to get the complete detailed information. Okay, I can use kubectl describe. In Docker, what we were using inspect. Okay, here we'll be using describe. So what you want to describe pod, right? So guys, one more thing. So for every resource, we have couple of different, we can use pod. For example, let me show you this. Okay, so earlier what I have executed here, if you see kubectl get pods, pods, right? So here I will execute kubectl get pods. So what is happening? Either you can use singular or plural. That's up to us. Kubernetes don't have any kind of restrictions with such kind of commands. Okay, as well as we have some shortcut names as well. Okay, for example, I'm not sure for pod. I think yes, no. kubectl explain API and resources. Sorry, not explain, describe. Not working. Okay, let me check this command. Okay, so basically we have some shortcuts as well what we can use in order to fetch the details. Okay, so now if you want to get the pods, we can use kubectl. What happened? Kubectl command is not working. Okay, spelling mistake. Okay, so give kubectl get pods, we can get the details of the pod, and this is my pod name. Okay, so if you want to get the more information of your pod, in this case what we can do, kubectl, we can use describe. Okay, and then we can use first pod. We can describe pod and then the first pod, the pod name. Hit enter, then we can see the complete detailed information of our pod. Okay, here if you see this, name is first pod, namespace is default. What is namespace? I will talk about this. Okay, and then on which worker node it has been scheduled, worker 02, and this is the IP of address of that worker node. If you see this 192.168.0.8, this is IP address of the worker node. Okay, and then this is the IP address of your pod. As I said, pod will be running on port number, pod will be having one IP. So this is the IP address of pod. Okay. And then we have here, if you see this container details, okay, this is our container ID. Generally what we see in Docker, right? So container ID, and the image which has been used is Nginx, and the image has been downloaded from here, and the state is running when this has been executed on 7:23 UTC time. Okay, and status is ready. So we can get complete detailed information, and also we can get the events from here. Means what happened, normal successfully assigned. Okay, first it has been assigned. Okay, and then the image has been pulled, and then successfully pull the image, and the container has been created, and then the container has been started. Okay, so we can see the complete detailed information by using describe command. So kubectl where is our command? Yeah, kubectl describe pod and the pod name. Okay, so and then we have some more commands, like for example, this we have already executed, right? So kubectl explain pod. So what will happen is, if I execute this kubectl explain pods, then we can get the complete detailed information of our pod object. Okay, each, I mean, pods, we have replica sets, we have replication controllers, we have deployments, right? So we call them as objects in Kubernetes. Okay, so when I will be using explain command, so what will happen, it will give me the complete detailed information, like the kind is pod. So with the help of this information, it will be very easy for us to write the YAML file. So as of now, what I have used, I have just used one command and I have executed my pod, right? But same pod, if you want to create with the help of YAML, then this command will help us with the details, because kind and version are something which might get changed. Kind will be same, but version might get changed with every update. Okay, if you get the addict of this explain command, then you will be able to understand how we can write our YAML file. Okay, so and then these are the different options what we generally write or mention in our YAML files. Okay, so with the help of explain, what we can do, we can get the complete detail of pods. If suppose you want to check for different object, for example, kubectl explain rs means replica sets. So if I hit enter, so what will happen, we can get the detail of replica set. So explain can be used for different objects. Okay, and then we have one command, kubectl get pods -w. So -w, what it will do, for example, okay, the moment I'll pass -w means watch. So the cursor is being stuck over there, and it will be watching our pod status. Okay, so this we can use when you want to do any kind of troubleshooting, or if you want to know what is happening with our node machines or our pods. Okay, so this is one command, and then we have, for example, if you want to delete the pod, whatever I have created just now. So if you want to delete that pod, what we can do, we can use the command kubectl delete pod, and then pod name, first pod. Okay, pod has been deleted. If I'll do kubectl get pods, then no resources found in default namespaces. Okay, if you'll do kubectl get events, so what will happen, if we have one command kubectl get events, so it will provide us the complete events which has been executed on our cluster. Okay, see, so first thing, say 25 seconds ago, what I have did, I have killed my pod. Okay, so we can see the complete detailed information what happened on our Kubernetes cluster with the help of kubectl get events. Okay, and then we have one more command, resource type. Basically, the resource type is nothing but our pod, and resource name is our pod name. Okay, if you want to delete any replica set or namespace, then we can use the same command kubectl delete, and the resource type will be namespace, and the resource name will be the name what we have assigned. Okay, so and then we have one more command, okay, dry run. So what dry run will do, Basically, what try run will do in Ansible? What try run will do in Ansible? What try run will do in Ansible?
Trident is used before execution to check the particular execution is correct or wrong.
Basically, try run will check how the changes are going to happen on our end servers. Okay, I mean it's a kind of Terraform plan or Ansible try run. So even we have same thing in Kubernetes as well. So if I'll execute this f1 try f1 run equal to client, so what will happen? So basically, this will only show what might happen when I'll execute this command. So what will happen? Pod nginx will be created, but in reality, if we'll do get pods, then we will not be able to see any pods. Why? Because there are no pods created. Okay, so dry run is only to check the behavior on the client machine. In our case, what is our client? Our client is our master machine. So okay, and our server are our worker nodes. Okay, so we are just checking what behavior will happen if I execute this command, only for safer side. Okay, and then if you want to delete all the pods, then we can use kubectl delete pods f1 all. So what it will do, it will delete all the pods which are running on our master machine. Okay, and then we have something called labels. So what is labels? So labels are generally, I mean, that's a kind of key value pairs which are attached to pods. Basically, we can attach label to our pod for the identification purposes. So what will happen is when we have 100 of containers, then how will you understand which container is has been created for which environment? So label can be any environment name or any different name or any city name. So whatever you want to provide, we can provide to the labeling. So if there are 100 pods, then with the help of labels only, we can understand which pods belongs to which particular application or how we want to map them. Okay, so labels are key value pairs which are attached to pods, replication controller, and services. So these are the three different objects where we are configuring labels. Okay, we'll talk about labels after some, I mean, in tomorrow's session, hopefully. So you'll get to know more details about labels. Okay, so they can be added to an object at creation time and can be added or modified at the runtime. So basically, we can add these labels at when we are trying to create any pod or any replication set or any deployment. Okay, we have seen one command called describe. So basically what we can do, so we can check if there is any labels created or not. Okay, so what I will do is first let me create one more pod. Okay, so kubectl run nginx -f1 image, sorry, kubectl run, and then the pod name that will be first pod. Okay, -f1 name equal to nginx. Okay, so if I want to get the complete information, I can use kubectl get pods -o white. Okay, so here to if I check kubectl describe pods, right? So if you want to get the complete detailed information of your pod, describe pod, and then first pod. Okay, so what is happening here? If you see, we haven't created any labels. Okay, if you see this, as of now, there is only one label. Okay, run equal to first pod. Even this is not considered as a label. I mean, it has been attached when we were trying to execute. Okay, so if you want to label anything, okay, like environment equal to test, we can use this command. kubectl label pod, and then this is my pod name, and the label will be environment equal to test. Okay, so and then if I'll open kubectl describe pod, here if I'll scroll up, okay, here we can find the labels. Okay, so here we have two labels, one is environment and one is run equal to first pod. Okay, so this is how we are going to attach the label. So if you want to override the label, existing label from, for example, from test to production, then we can use this command. Okay, so let me show you this. Okay, kubectl label f1 override pod first pod environment equal to prod. So earlier it was test, now I want to make it to production. I haven't executed this. So kubectl get prods f1 show f1 labels. Sorry, f1. Okay, here if I'm executing this command, so here we can see different labels which are attached to my pod. Okay, so if I want to override any label, for example, from environment test to production, then in this case I can use this command --- override parameter. Okay, and now if I try to check the labels, then we can see environment equal to production over here. Okay, so we can create, attach any label, and then we can update any label as well. Okay, and this is to check the labels command. Okay, so this is how we can create any pod by using a simple kubectl command. Okay, and how to get the detailed information of the pod, where that pod has been scheduled, and also we can see how can we create a label to our attached pods. Okay, I think we are good for today. So if you have any questions, then let me know, or else we can drop off. Guys, do we have any questions? So the only thing what I'm expecting from you guys is not to write any notes on this, but try to execute each and every step which has been shown. Okay, do not waste your time in writing all this content, listening to the videos, and again writing up the content. Okay, listen to the video and start execution. Okay, and again at 4 o'clock I will be taking one more session on to check if we have any doubts on this. Okay.